Programming Throwdown, episode 49, Tamper Protection. Take it away, Jason.
Hey everyone, this is a double episode, December double episode. Pretty excited about that. We have an amazing interview coming up, and we want to give a lot of time for that. So, we'll skip a lot of, we'll usually cover in the beginning of the show and save, our tool of the show, book of the show that we had lined up for next month. But something I did want to talk about is, what did things cost and why did things cost what they do? So someone sent me a YouTube video, a coworker sent me a YouTube video called Most Expensivest Stuff. It's not stuff, it's actually the S word, but you can figure it out. But it's a show where they just try, they drive the most expensive car and they try on a $2 million pair of shoes and things like that.
What?
Yeah, it's crazy. It's really funny, actually. And so it made me think, okay, these are extreme things, but in general, why do things cost what they cost? Kind of who figures that out? And, we all took economics in high school. And you talk about, the supply curve and the demand curve and all of that, but it doesn't really explain sort of why those curves are what they are for different things, right? So I did a bunch of research on this, poking around on Wikipedia and reading some papers and things like that. And basically what I learned is there's a lot of different theories, and they're all true, to different degrees for different products. So I'll just kind of go through them. The first one is called the labor theory of value. And it's very simple. It just says things are worth whatever it costs to produce them. So, if something's really hard to produce, such as, way back in the day, salt was used as currency because it was so valuable. And it was valuable because it was very difficult to mine salt back then. Now it's very easy to mine, so it wouldn't make a good currency, obviously. But so that's the idea. And so but then that kind of breaks down. I mean, if it's just because something is difficult to get doesn't necessarily make it useful. I mean, panda bears are rare, but, they might be difficult to find, but, panda bear feces isn't worth a ton of money, so it can't just be, that was a stretch, I know, but it can't just be how hard something is to get. It doesn't make, that by itself doesn't work. And so then they came up with this idea called the subjective theory of value. And this handles, there's, take diamonds, for example. Diamonds are more expensive than emeralds, but they're about the same in terms of how hard it is to find them and things like that. But diamonds are more expensive just because it's part of our culture to give diamonds. So it's sort of we've just propagated this value for diamonds for no reason. There's nothing inherently about diamonds that make them more expensive than emeralds. And so that's the subjective theory of value is kind of weak, right? Because it's just saying, well, things cost more because they cost more. It doesn't really help. But the reality is that there's a psychological, there's sort of a group mentality, mob thinking part of this, and that just reflects that.
Well, this is the diamonds are supposed to be colorless, but then so if your diamond has a tint of color to it, then colored diamonds, and then now they become more valuable.
Exactly. Or even more ridiculous is you can get a synthetic diamond that chemically is exactly the same from a chemistry perspective as a diamond, but it's almost worthless, relatively worthless, right?
Well, no, they charge a lot, and I don't know if they need to or they just do, or if it's a conspiracy. But I think they only charge 10% difference or something.
Oh, really? I thought it was a tenth of the price.
No. I mean, cubic zirconia or something is a tenth, but those are chemically different.
Right. Oh, okay. Well, yeah, but you're right. But the point is, they're a chemically the same diamond
But the fact that it is different at all.
Yeah, exactly,
Yeah.
exactly. And so there's that to think about. So now you have this labor theory, you have this subjective theory. There's also one called marginalism, or the theory of marginal utility. And the idea there is the value of something goes down, the easier it is to add another one to the ecosystem. So in other words, if you look at, say, a loaf of bread, if you compare, you might only have one or maybe no loaves of bread at your house. And so you have to go to the store, and for you it's very important to get some bread right now. But if you look at the whole ecosystem for, Safeway or Kroger or Publix or whatever supermarket you have near you, for them to add a loaf of bread to their network is very simple. I mean, the bread manufacturers are probably stepping on bread all the time by accident because there's just so much bread that they're producing. And so the marginal utility of bread is tiny. The same isn't true of diamonds. I mean, you don't go to a diamond factory and just see a bunch of discarded diamonds everywhere because there's just, each one is too hard to come by. And so marginalism is kind of connected to the labor theory, but it's not entirely that way because, for example, if you're out in the desert and you don't have access to any stores or anything, water becomes extremely valuable, and it didn't make water more difficult to produce. It's just that you're in an environment where you don't have access to a lot of water, and so the marginal utility goes up. So marginalism, think of it as sort of replacing the labor theory of value, kind of. So basically there's all of these different theories. They're all true in different circumstances, and there's no way to tease apart, what kind of is assigned to what. So you can't say, oh, diamond, 90% of the value is subjective, 10% is this, it's very hard to do that.
So how do you break down something like an iPhone? An iPhone costs, what, $600? I don't know, unlocked a new iPhone.
Mm-hmm.
I don't know.
I think
let's
it's
say
like
$600.
But yeah, sure.
Sure, 700, 600, whatever. And then you always see whenever the new iPhone comes out, they say, here's how much the actual components cost, and someone tries to do a really good job of estimating it, and it comes to like $120. And so you have $120 of like materials cost. Then there's some labor to assemble iPhones,
yep,
and some labor to develop iPhones and the software that goes on them. But then there's all this extra at the end, like the profit margin. And is it a theory to say, predict how much Apple should make that profit margin?
Yeah, I mean, it's super hard. So I'll talk about, so iPhones are a restricted commodity in the sense that, Apple just sets the price, right? But if you look at open commodities, like say oil, for example, so with something like oil, it turns out they can't really do a good job of teasing this apart, and there's no science to it. So what they do is,
because only Apple makes iPhones, but everyone who makes oil makes the same oil.
Right. And so nice. They can't control those dynamics because it's just too complicated. And so that's why they have futures. So if you want to buy any commodities, I mean, if you buy a loaf of bread at Safeway, it's different. But I mean, if you're buying, 10,000 tons of bread or something, yeah. Or a ton of oil or anything like that, that level.
Barrels of oil.
Oh, right, barrels of oil. If you do any of that, there's a commodities market, and you have to say in advance, like, 3 months from now, I want these barrels of oil. And then there's, in the case of oil, there's OPEC, who they handle this socially. So in other words, if something weird happens and everyone starts asking for oil, they, through phone calls and things like that, they just sort it out manually. Like they decide they need to do an auction, or they call people and tell them, hey, your order got canceled because crazy stuff happened in the market. And basically the free market isn't really that free is what I learned.
Well, OPEC specifically is not that. Like, they control the market, they manipulate it.
Yeah, well, that's even worse, right? But even if you look at grain, almost any kind of utility, It's all just very highly regulated. So I'll give you another example. So in the Bay Area or in all of California, we have a drought, right? And so when there's a drought, they don't just raise the price of water until the demand goes down. That's what a free market would do, right? But no, they impose restrictions. They say, people can only water their lawns on Mondays or something like that. And basically, it's because they know that if they try to do some kind of free market economics, it's going to end badly, basically, because their models are wrong. It's hard to decompose the price, and it's just going to end badly. So it's kind of amazing. I mean, I'm not trying to be glib or rude to economists or anything. I think that's amazing. I wish if I could go back to school, I would study economics. And
Really?
I have a lot of, I give them a lot of credit. But the reality is these systems are just not modeled well. Whether they can be is debatable, but right now they're not modeled well. And so there's a lot of social, a lot of elbow grease goes into making this work.
The thing I remember about economics is a lot of it comes down to like predicting what a rational person should do. But then there are many edge cases that break down because people aren't rational often.
Oh, that's even worse. Yeah, that's a whole other thing. You're right. I mean, it turns out even if people are rational, the system is completely unstable. There's something called the bullwhip effect, which you should look into. And basically, it's similar to the butterfly effect. It just says that if you make small changes, like you just barely change the price of, say, an iPhone or a barrel of oil, it causes massive change. Like you change the price of a barrel of oil by a cent, and that causes an oil field to get shut down because there's this weird chaos theory going in there. And these are all assuming everyone's rational. They're just using mathematical models. As soon as you get into real human beings, it's even more broken. Yeah, it's unbelievable. So, anyways, that's my pseudo rant. But that's what I learned from most expensivest stuff, or from, I guess, the queries that derived from that. Anyways, if you wanted to check that show out, it is actually really funny. They don't obviously talk about why things cost what they do, but they have fun, putting on 2 million pair of shoes. All right, so without any further ado, we're going to talk to some folks at Intel. These guys are superstars at software tampering and tamper protection. They've done definitely their fair share of, I guess you'd call it gray hat and white hat hacking, and it's going to be a lot of fun to talk to them about this.
Well, welcome. We're here with the team from Intel, the Tamper Protection division, I guess, our team. We'll let them introduce themselves in a minute. We've got Thaddeus, Mark, Steve, and Norman. So we're just going to go around the room, the proverbial virtual room, and have everyone introduce themselves. So I guess, Thaddeus, you're up first.
Hey, I'm Thaddeus. Call me Thad Letness. I work over at Intel. I've been there about 10 years. Used to work in the digital home group doing things like the Google TV and stuff like that. A year or two ago, I moved over to Steve and Mark's team and been working on tamper protection ever since.
Mark?
Yeah, so I'm Mark Valley. I've been at Intel for almost 17 years now. I started out at the University of Florida as a mechanical engineer in my undergrad and did master's in computer engineering, and never thought I'd come west of the Mississippi, but they decided to fly me out here on their dime, and I really like what they had to offer, and free flights and a nice warm weather just like Florida will do that for me.
Go Gators!
And so now I'm
nice.
Yeah, absolutely. I don't know how we got the record we got so far this year. So
That's all right. Hey, at least I think you won a game.
What?
I went to University of Central Florida. We went 0-12.
University of Florida won many games this year, I think.
No,
I know. I'm saying.
Yeah, but UCF is.
Yeah, UCF went 0-12.
UCF is up and coming. I mean, they got a lot of the Florida talent, so I think they're going to do all right in a few years.
Yep, it'll
All right,
recover.
Steve.
But yeah.
Hi, I'm Steve Price. I'm a product manager at Intel, and I started my career as a software developer. And if any of you have some age, you'll remember WordPerfect. I was a developer of WordPerfect for Windows, or one of the many developers, and then I had the opportunity about 18 years ago to work for Intel. And Intel, you can do amazing things. It's not just on the commercial. It's a real great place to work. And so I product manage a brand new tool called Intel Tamper Protection Toolkit. And we are excited to tell you a little bit more about that in this podcast.
Very nice.
Cool. I didn't know for the longest time what product manager was. And then I read one of the books of the show. I don't remember which episode, but it was The Hard Thing About Hard Things by Ben Horowitz. And he explains, he developed this training class for his product managers, and he called it Good Product Manager, Bad Product Manager. And he used sort of that dichotomy to explain what a product manager does, and it totally made sense after that. So if you guys wanted to know what product managers do, definitely check out that book. I felt like it really kind of explained it. The summary is you're CEO of the product. That's
not a bad one. I would say my description is very close to that. It's the guy that does the stuff that the coders hate doing. That's my job.
Nice.
All right, Norman.
Thanks, guys. My name's Norm Chow. Can you hear me?
Yep,
we can hear you.
Yep.
Yeah, my name's Norm Chow. I am the marketing person for Intel Tamper Protection. I've been with Intel for 5 years. I love every minute of it. Before that, I was actually a pure Windows coder for 5 years, so I bring a lot of technical experience. And, I really appreciate the engineering team coming on this conference call and kind of describing the product to everyone.
So I think we'll have Steve give us maybe a little bit of, or whoever you think is best. Steve give us a little bit of overview of what's going on, and then we'll go over to Jason in order to get some questions going for the team.
Perfect. So when you think of Intel, a lot of times you'll think of the bong tone that you hear on the commercials, and of course the chips that we make for CPUs. But Intel produces a lot of software to make that hardware fly. And my team comes from the software side. And being a part of Intel, we're in the position to see a lot of the general needs in the software development community. And what we've come to understand is that coders, whether or not they want to or not, most of them don't want to, is they have to put secrets in their software. And coders will do a lot of interesting things to hide or mask those secrets, but at the end of the day, you'll have to put in either a account name and password, or a crypto key, or your secret sauce that makes your code better than anyone else's. And so while they're not comfortable in doing that, they still have to write and ship their code. Another thing that we've found is that developers want to do wonderful things with their code, and they want to achieve personal goals and help other people. But while doing that, they want some say in how their code is used. And so we at Intel, understanding these needs in the marketplace with a lot of the really smart people we have developed technology that helps you hide your secrets in your code, and that lets you be able to respond when people try to modify your code without your permission. And that collection of capabilities and technology we call Intel Tamper Protection Toolkit.
Cool. Thank you. That was an awesome intro. So just to kind of recap, so I think a lot of people, you hear these terms like reverse engineering or code tampering, and especially, you see it in the press, like someone, reverse engineered some project, they were able to get in, or hackers reverse engineered some client and now they could get into Target or what have you. But what does that actually mean? Like if someone tampers with a binary, or if someone reverse engineers some code, what are they actually doing?
So reverse engineering it's kind of the process of pulling apart source or binary code, machine code, usually, although in this day and age we have all sorts of scripts and stuff as well, and trying to piece back together what the original logic was. It's going to be things like disassembling the code, so going back from machine code to assembly, trying to reconstruct the flow, the structure of the code, and understand the idioms that the compilers and stuff were putting in, with the ultimate goal of being able to say, here's a function that does exactly what the original programmer wrote.
Gotcha. Is that the same as tampering, or is tampering something different?
Tampering usually starts with reverse engineering. You usually have to have some idea what you want to do. But tampering then takes it another step forward and says, I'm going to go and take your DLL or your code loaded into RAM and make some change. Maybe tweak a variable so that it's always a particular value, or change an if statement so it just unconditionally passes. So you can maybe to bypass a license check, or a great example is the old Game Genie, right? Any code you put in the Game Genie was basically code tampering. It said, here's an address, here's a value. Whenever somebody wants that address, give them that value.
Oh, I actually never knew that. So for people who maybe are younger in the audience, Game Genie was this amazing magical thing that you plugged into your Nintendo, and it plugged into the Nintendo, but then it offered a plug out, so you could plug a cartridge into the Game Genie, which is plugged into the Nintendo. So think of it as sort of a connector that sat in between. And then when you started the Nintendo, it just presented you with this crazy screen like you would see in some sort of cheesy CSI episode. And you would punch in these alphanumeric alphanumeric entries that were completely cryptic. But when you were done, you would get them from some kind of reference manual. But then when you were done, you just had infinite lives, or Mario could fly or something like that. And so I guess that's under the hood. That's actually code tampering that's making that happen.
And in order to find out exactly what values to punch in and how to build that thing, they had to reverse engineer both the Nintendo and the software first.
Mm-hmm.
Oh, I see. So in this case, were they? Do you think they were working with the software company, or were they actually reverse engineering it blind?
Well, in the Nintendo world, I thought they had to have permissions and stuff. But certainly you can think of other platforms where back in the Commodore 64 days and stuff like that, there were things like this as well, right?
Mm-hmm.
Oh, I see. That's right.
Game Genie probably not, because that was there were licensing issues with that back in the day. So Nintendo would probably jump on you.
Yeah.
Cool. Yeah.
So obviously they didn't have the source code for any of Mario or anything like that, so they had to completely figure out by sort of poking around what they could modify to get behaviors that they wanted instead of just crashing it.
Mm-hmm.
Gotcha. There's actually a lot of these sort of bootleg cartridges. There's this Noah's Ark game. It's actually a set of 3. It's called Bible Games, I think, or Bible Study. But it was an NES cartridge that was not licensed in any way by Nintendo, but they were able to sort of handshake with the Nintendo and convince Nintendo they were a licensed cartridge. And it's probably by doing exactly what you said, by reverse engineering the input-output of the Nintendo.
Yeah, in fact, there was a whole, I forget where I read this, but there was a whole series of games by one manufacturer that actually did reverse engineer the handshake chip and started making these third-party unlicensed games.
And the big deal with that was that Nintendo's revenue model was that they got a cut from everybody's game. So there was some incentive for these guys to bypass that so that they can get a cut themselves.
Oh, I see. So they didn't have to pay that share.
Exactly. They could just sell that to the consumer, and any additional money over the top they got, or they could lower the price of their cartridge.
Oh, interesting.
That starts to show of the battle between developers and commercial entities. You're always wanting to get paid for your products, and so you put in code, and then somebody reverse engineers it and finds a way around it, and so then you do something more to lock it down even more. and there's a lot of benefit sometimes. The new Nintendo stuff, and the emulators and stuff, we're able to unlock a lot of games having reverse engineered a lot of the old Nintendo equipment. Now you can play games that aren't manufactured anymore. The hardware is slowly going out of date, but we can still play them thanks to people diving into the software and reverse engineering how they worked.
Right. Yeah, one thing to understand about that whole ecosystem is that we can reverse engineer them now, but it took time. I mean, ultimately, given enough time and resources, you can pretty much eventually reverse engineer everything. It just may be really expensive or it may take a really long time. So your goal as a developer may not be that they never can break it, because that's almost impossible, but to make it hard enough so that only someone who really is super motivated would do it, and hopefully there's not going to be that many motivated people. I mean, if you're storing, the keys to Fort Knox in there, there's going to be more incentive than if you're just storing, some game secrets or something.
Gotcha. And I think that Moore's law plays a huge role in this. I know this is more on the cryptography side, but if you had Amazon Web Services, not S3, but Elastic Cloud, Elastic Compute Cloud of today, and you went back to the 1990s, you could actually break HTTPS, and you could just liquidate people's bank accounts, and you would just be a god on the internet. And so that just furthering your point that given enough resources, nothing is completely secure. But as you said, it's this constant arms race between in this case, just going back to Nintendo, between Nintendo, who's trying to preserve their intellectual property, and various people who are trying to do the reverse engineering to increase their bottom line.
And that goes the other direction too. When you get to the 2030s or so, don't expect your PGP encrypted stuff to work with quantum computers around. So anything you
Right, exactly.
Yeah, and what we found too is that there's tight Fort Knox security. I think Mark brought up Fort Knox, but then there's good enough security. You just need to be a little bit better than the other guy, so that when they come to you and their easy tricks don't work, then they might go looking for better targets of opportunity. And so you don't have to be super secure, but just more than you were before, and that buys you a lot of value.
Yeah, and that goes with understanding your threat model. In other words, what attacks are you expecting? I mean, as security engineers, that's something that we often think about when we're architecting solutions. I mean, obviously, we can't protect against the nation state attack necessarily, but you can, at what level of resource are you considering?
Gotcha. It's very similar to guarding anything, guarding your home or guarding your locker in school or any of that. Sure, someone can come by with wire cutters and cut the lock of your locker, but that's a very high. I mean, someone's going to be seen walking around campus with lock cutters, and that's already introducing a lot of risk for them. And unless they just really hate you for some reason, it's just not worth it. So by putting the lock, you haven't sort of eliminated completely the idea of someone breaking into your locker, but you've made it prohibitively difficult.
Mm-hmm.
So what are some reasons why, we talked about Nintendo and about Bible games, but obviously that was I guess 20 years ago. So today, what are the big reasons why people tamper with binaries? And so who are the people nowadays who are tampering with binaries?
Well, there's a bunch of reasons. I mean, one of the big ones is curiosity. A lot of the people who poke around in binaries are, students or, hackers in the good sense of hackers, people just who enjoy, peeking into how stuff works. People who want to fix bugs. If there's a driver for an old printer and it doesn't work, with Windows 10, somebody can go in and figure out how that driver works and fix it. And usually that's to everybody's benefit, including the printer manufacturer. Could be to add functionality in a similar way with printers, maybe to add a new format for sending messages.
Or new cheat mode.
Yep, or cheat mode. Getting into some of the more nefarious reasons. Bypassing authorization checks is a big one. This might be for things like DRM or license keys for software. If you're downloading wares, you find the cracked version of the program, right? Spreading malware. A lot of the way that malware spreads is by infecting other binaries, and so there you're diving into the binary and finding somewhere to stuff your malware, and then generally just to maliciously change behavior. If you want to sneak a man-in-the-middle attack in to sniff somebody's financial information as they're doing transactions online and that sort of stuff, if you can hop into the browser, that's a good place to do it, right?
Oh, I see. So you look for some code that handles the, when you type in your password and it turns it into little asterisks in the browser, like you would inject something right there and know that you're getting, hopefully for the attacker, you're getting passwords and things like that. Okay, that makes sense. Are there, as far as so you mentioned hobbyists, are there also, is this mostly individuals? Are there, is there organized crime? Are there massive entities that are doing this?
Oh, heck yes.
Or is it mainly people in their basement or what?
If you look at, it's getting more and more organized all the time. If you look, there are international gangs now that it's not drugs anymore, but it's all about, hacking stuff. Very well organized, pretty scary groups that, do all sorts of, things that are very financial nature. They're very much organized as businesses and not, they're not the lone hacker in the basement that you'd think of.
Yeah, so I was at Black Hat this last summer, and they were showing the nature of what you call malware or the black market industry, and you can go and you find the right places, and you can find a hacked kiosk, let's say, for on the market that whoever hacked it is selling it now for someone else to exploit or to get gain from it. So there's a lot of activity, a lot of it very organized with very, very skilled people out there just wanting to benefit from from others, and so it's a very vibrant market, if you could say.
Gotcha. I had something. It's not totally along the line of reverse engineering, but I was trying to get my Windows product key before I upgraded to Windows 10, just in case something went wrong, and I was extremely careless and ran this program that gave me my product key and also installed something terrible. And before I could remove it, it had gone into my browser kind of local settings and pulled out my credit card. And sure enough, the next day, someone went with my credit card to Home Depot and bought a bunch of restricted chemicals.
Whoa.
Which is actually quite terrifying. They bought things that you can only buy in certain amounts, but because they were masquerading as me, they were able to buy more than probably they would have by themselves. And that whole thing is just frightening. It screams of a huge organization, right? Cool. So I think we've kind of, sort of touched on this, but what are the consequences for not protecting against tampering? If someone just runs regular old, GCC produces maybe GCC with debugging symbols and no optimization and starts distributing the binary, what are the consequences of that?
Well, the big one is usually the money motive, right? Lost revenue if people are able to install your software without a license. Possibly legal liability if you're supposed to be protecting, say, somebody's financial information or content that you're licensing, and you let people bypass your DRM. You could actually be liable for that. A big one that we think about is reputation. Just somebody being able to get in and monkey with your code and then make you look bad.
Bad press, yeah.
Yeah. Within Intel, we look at things like loss of intellectual property, like trade secrets, stuff that isn't actually patented but shows how stuff works. Usually,
That'd
don't
be
want
algorithms.
Yeah, generally, if you've got an algorithm that is really that much better in your product, then you might want to protect that so that somebody else can't get at it. Possibly loss of customers. If you got like if your mobile payments get hacked, then people are going to stop using you. Take a look at Chipotle if you want to see how fickle people are nowadays, right?
Yep.
And it can even be life and death. More and more we've got things like traffic lights and power controlled by computers, even airplanes and cars, right? With the computer controlled cars nowadays. So if somebody can hack in and gain control and get their software running where yours should be, somebody could lose their life over it.
Yeah, I guess that's a good point. I mean, I think a lot of times hacking is the vague term that people use. And, initially it's like, oh, you're going to talk to some web service and try to understand its behavior, and then you're going to try to send it some code, some exploit, whatever. And I mean, I guess...
Right, some kind of like black box
Yeah, that's one
hacking.
way of doing it. But the other way is, like you're saying, if you're running a server that's a program and someone can get that program and look at it and figure out by looking at the source code, like, oh, hey, look, there's a, not bounds check string print here. Oh, well, now I know exactly what to send it to hack it. Then that's much worse.
Which is exactly what stuff like Heartbleed was, right? I mean, somebody sets up an overflow and all of a sudden they can start whatever code they want running on your server. There's not much we can do about that from the Tamper Protection side, but if their code starts to interfere and interact with protected code, we can at least identify that and, stop it at that point.
So does the Tamper Protection work at all with like the trusted security modules that are in some computers, or is it that kind of unrelated?
So Tamper Protection is a software sort of trusted execution environment. So there's no special hardware required other than IA. So in a perfect world, everyone would have the very latest SGX technology that's in the latest Skylake processors, and they'd use that sort of hardware protected execution environment. The problem is that very few people have those right now. And let's say you're a Netflix and you want to deploy something. I mean, you'd love everyone to have Skylakes, but realistically, you want to sell to a lot of people, and not very many people have them yet. So until those are widely deployed everywhere, you're going to need some stopgap until you have hardware support.
Right, and I think if you're in the business of tampering the binary, you would just get some older hardware to do the tampering. I think, right?
Well, I mean,
presumably.
Well, if you waited in time, I mean, once everyone has a protected hardware execution environment, then it's going to be much harder to tamper in the same ways.
That's actually might be a good topic. You want to explain what I brought it up, but you want to go ahead and explain maybe what hardware modules, what what a trusted execution environment, like what does that mean?
So what that typically means is that general code running on the computer can't see into what's going on. Imagine it like a sort of a little box somewhat. So a great example of this is you can imagine that if you look on an older PC, there's this thing called the ME, the manageability engine. If you have an Intel processor, and the manageability engine is actually a separate processor that is not it's sort of an embedded device, and the main CPU cannot access its memory, cannot talk to it in any significant way, so it can't really inspect what's going on. So you can think of the thing that processor is running as an environment that's protected from the CPU. So that even the OS, if you somehow compromise the OS, you can't see what's running on those things. And similarly, with the latest Intel processor, the Skylake models, you in fact can do that on the main CPU in such a way that the main CPU can't actually see what's going on either in the process itself or even in memory, because the memory is encrypted from the other parts of the CPU. So even the OS doesn't have the power to go in there and see what's going on.
Oh, I see. So that protects you against sort of attacking the OS or attacking other binaries, getting into I guess like Explorer.exe and things like that.
Right. But if you attack it,
right,
you have to have a program. So let's say you have some hacking tool that can write to memory. Well, the problem is that the memory that you're writing to is essentially not accessible to even that tool. So there's no other program that can run into that memory other than the program that owns it.
Oh, now I get it. It makes the discovery of the hack very difficult.
Well, it's literally impossible.
Yeah,
right,
and
right.
Also, let's say that you're a programmer and you're writing code either in your basement or you're part of a small company, to get a piece of software on the manageability engine is a difficult proposition, right? Because it's a secure environment. And very few people write to that level of security or to, that have access to get their software on that engine. And it's, as Mark said, it's a separate computer, almost within a computer, intended to run securely. But what a lot of developers want to do is they just want to write their code. And they want to be able to write their code in such a way that people don't mess with them. And so what we provide is a software trusted execution environment. As we said, it's not impervious, but it's better than nothing. And it's a way that gives you a little bit more comfort and security to know that when you write your code and you have to put your secrets in, or you want to be able to detect when someone has changed something to get a different behavior, then you have some avenue and recourse as a developer to either minimize the impact or at least slow them down to the point to where they'll think it's not worth the trouble and go on and mess with someone else's code.
Gotcha. So that is a good segue to the next question, which is how does this actually work? In other words, are we talking about something that scrambles your code before it compiles it? Is it its own compiler? Is it a virtual machine? What is actually the tamper protection product?
Well, I'll just take a product manager's crack, and then the real answer will come from the geniuses. But really, if you look at Tamper Protection product, it's basically two main components. One of them is a command line executable. We call it iProt, Intel Protector for long, but it's an iProt. It's iProt, and it's a command line. You type in some input parameters, and you include one of those parameters is the input file. And this input file is your binary. It could either be a Windows binary or an Android binary, DLL form. And then it spits out another executable that will run on any Intel processor, but this one will be self-encrypting and self-modifying. And so the difference between the input binary you give it and the output binary it spits out is the same identical functionality, but as it runs, it will be encrypting itself, unencrypting itself, modifying the code to make it very difficult for someone to figure out what's going on. So that's one component, and that's a command line executable. Another one is a library called Code Verify, and how that's used is you weave the Code Verify into your code, and what it allows you to do is reach out from this trusted executable environment. So just going back to iProt, the binary it spits out, we call a software trusted executable environment. And from within that base, then you can reach out to other unprotected pieces of code and check it. Are you still the same piece of code that I expect you to be? And if it isn't, then we can flag it. And because it's in a TEE, it becomes difficult for an attacker, let's say, to change the signal from 0 to 1, from a yes to a no, for example. So that's pretty much it's very simple. We have some other ancillary pieces that help developers do their work, that help with what we call code bind, that lets the verification piece check a predefined a version of the file, so you know when it's been changed. But pretty much just a security compiler, you can call it, and a library that helps you go out and check and verify the integrity of your code.
Yeah, to speak a little bit to sort of like the workflow of how you'd work. I mean, if you're using something like GCC or something like that, essentially, you would take your program and separate out what you think the critical sensitive functionality is. I mean, you don't want to necessarily put the whole program in this because it has performance consequences. And then that turns into a shared library, either an SO or a DLL, depending on what platform you're going into. And then that is your sort of root of trust, your thing to start with. And so you compile it through GCC, you get an SO out or a DLL, then you run that DLL through our tool, and then you have a new DLL with the same entry point, same functionality, but it's not going to be very easy to tamper with or reverse engineer.
And that's for iProt.
Yeah.
And then for the Code Verify technology, you take a binary, exe. I believe we can even take exes for that. I know DLLs and SOs, and you generate basically it's like a cryptographic hash signature of that file using a tool called CodeBind that I think Steve mentioned, and then from that, you can check all or even just parts of your execution file against that. And that's kind of the lightweight, relatively fast iProt output because it's self-modifying. And in fact, it keeps very little of the executable code in plain text at any given time. So as you're running, it's constantly trying to pull stuff down and transcript it to the next phase of execution. So there's a lot of heavy-duty processing going on there. So that's the heavyweight thing. You want to be in as little as possible, only for your most secure code, and then jump out to this much faster engine. For more of the general, is my code still untampered?
Could you maybe walk us through the flow, like a function level, like what kind of function? So you said you wouldn't want it all to be there. So your main is running, you're doing something, you want to log a user in or whatever. Like what would be the kind of thing you would want to do where you would jump to the environment and then come back? And how does a person not just bypass the trusted environment? Like how do you prevent them from just not going there?
Okay, great question. So the first way you do that is you've got to put something of value in the trusted environment. In other words, something that if they were to just rip out and skip it, then whatever functionality that your code performs would no longer work. So one example we could have here is, let's just say we're doing a video decoder, for instance. And then the video decoder is decrypting some video stream, and then it has a decrypt functionality, and then it passes that video stream on to some other buffer in decrypted form. And let's say you don't really care so much. Once the bytes are decrypted, they're uncompressed, so there's lots of the size of the video is huge, so you're not going to. No one wants the raw bits, but you want to protect the encrypted bits from easily being transferred around. So one attack would be, hey, I'm just going to call your. Well, the first attack would be I'm just going to look at the decryption keys inside your sensitive application. So that's an example of something that you might want to protect with iProt. So you typically put the actual decryption stage in there. And the issue you have though is, so let's say anybody can call this. So I'm going to keep your thing as is. I'm not going to modify it. I'm not going to hack it. I'm simply going to call your API, and then I'm just going to grab the decrypted bits and hey, I'm good. And then I can write them to disk and do whatever. So that's one place where you can use code verify from there. So what you can do is, when you're ready to pass the bits off to some other module in your system that does the next thing with those bits, you can make sure that the one you're handing it off to is not some rogue application or rogue program or modified program that's going to write it off to disk or something to a file, but it's going to be the expected module that is the display driver or something like that. And that's where you would use code verify to sort of inspect it before you hand the bits off every cycle of the decrypt. So, an attacker to bypass that would have to extract the key, which is more difficult, or they would have to find some way to modify something in the chain to be able to write it to disk. So those are the things you want to avoid.
Yeah, Mark,
that makes sense.
I was just going to say, Mark in the past has described that scenario as a decrypting fool, and so someone hands you, they isolate the module that does the decryption. And they say, oh, okay, I just hand it some encrypted bits and it's going to spit me out the good ones. And if the thing that does the decryption can't identify who's calling him and enforce that it's the one he expects, then that's the decrypting fool scenario. And no one wants
so you
that.
Can use no. So you can use code verify. In addition to checking your downstream who you deliver to, you can check your callers to make sure that they're authorized to actually use you. So if you do something sensitive, like you say, if you do something like return passwords given a username, you can make sure that only someone who's authorized to ask for a password back from a username or whatever, or you're a safe and you're opening the safe. You only open the safe to authorized components.
So then people can't just pick up your code and use it wherever they want, and who cares what it's inside of it.
Without modifying it, and that's where the iProt comes in, is that in order for them to be able to modify it in such a way to bypass these checks, that's what makes it hard. So you need the iProt as sort of somewhere safe to stand before you go out and do all this checking. Because otherwise, if they just change the checks, then it's all for naught. I mean, like if you were to write this without iProt, as a reverse engineer, what I would do is I'd find out where the if check is. If this module is trusted, and I just always change it to unconditional, go ahead and assume it's trusted. So you need to make sure that attack is hard to do, so that the check isn't a waste of time.
So can you kind of walk me through so there's this machine code, and I have this, and there's these. I think there's like IDS is one of them, but there's a bunch of these decompilers that you can download off the internet, and you end up with, and correct me if I'm wrong, but I believe you end up with, C code with some assembly woven in where it couldn't do anything better, and the C code it tries to, you end up with ifs and a little bit of logic. Of course, all the variable names are, A, B, C, D, because those aren't preserved, right? And from there, that's how you would do things, as what you're saying. Like, you'd find this if, maybe you'd step through this C code that you've generated through decompiler. You'd recompile it and walk through it and see, oh, this line right here is where it's checking for the CD key, and I'm just going to delete that code or make it always true or something.
Exactly.
So if you try to do the same thing, you get one of these decompilers off the internet and you run it on a binary, and just assume that the entire binary is under tamper protection. So what does that look like? Is it just like a complete mess?
I ran IDA Pro for curiosity earlier this week, actually, on one of our binaries, and that has a
very expensive tool.
Yes, that is a very expensive tool. It's more for disassembly, but it takes the disassembly apart and creates a program flow structure like you're talking about. And when I did it against the unobfuscated code, it showed me a really great flow, mapped really well to the original structure. When I looked at the encrypted code, I saw a couple of assembly instructions and then a couple of blocks of stuff going off, writing to random memory, and then it just ended in a call to an undefined function, which is actually, knowing how it works, that was what I expected to see. But really, it can't go beyond that, because most of the time, the functions that are being called are either ones that we write ourselves as we go, or ones that we have decrypted along the way as we've been mutating the assembly code. And in fact,
oh, I see. Now I think it's kind of clicked. So what your program does is it creates something. It creates a binary that just cannot be represented as a source file because of its self-modifying nature. Yeah. Like there's no sort of there's no C syntax that could exist that could explain what's happening after
you would
this
actually have
modification.
to step through every possible phase of execution, track down every path that it traces in order to figure out what instructions would be executed, because at any given static point in time, most of them are going to be not just encrypted, but have been encrypted multiple times and have to be decrypted multiple times in order to be visible.
Yeah, what these tools typically do, the IDA Pros and things, that's what we call static analysis. In other words, they take a look at the binary state on disk, and they try to reverse engineer it as best it can from that state. The issue is when you're having things that are constantly being encrypted and decrypted, at every stage, ideally, you would want to run it while it's running, not just simply at rest, because there's nothing it can tell you about the encrypted code until the code became unencrypted. And the way our tool works is that only a very small portion of the code at any point in time is ever in the clear. So it's much more work to be able to do that sort of analysis.
And the other advantage of that is we actually use that code as part of the key to encrypt. The code at one state is part of the key to encrypt to the next state. So if you make a change, it starts to become this cascading reaction that ultimately generally results in protection exception of some sort that will cause the processor to throw back to the OS and kill the process.
Exactly. That's the primary way we protect against tampering in this environment, is that by modifying the code, you're modifying the decryption key, which results in decrypting perfectly legal instructions that are total garbage that are bound to lead to a crash.
Cool. Yeah, that's awesome. Yeah, thank you so much for explaining that. Really, it took me from a complete Luddite of reverse engineering and tamper protection to now I think I could explain to somebody how it works. So that's totally awesome. So for other people like Patrick, I don't know about Patrick, but for other people like me who know absolutely nothing about reverse engineering tamper protection, but want to get into this line of work, and just, they think it's that it's very exciting, and they want to learn more, and they want to be doing sort of what you're doing. What kind of, maybe they're still in school or they're thinking about going back to school. What kind of background is useful for this work?
So not Java. So,
All right.
so please, one of the things we're actually hiring right now, we're trying to hire people, and it's very challenging to find people nowadays who understand how the machine works. I mean, not just, what happens in the stack, what happens, how stacks are laid out, what happens when how function call happens, how pointers work, just, that layer of understanding of how the machine works. So an interest in not just at the top level, like quote unquote coding an application, but understanding when you say something in C, what are you really telling the machine to do? So things that you might do in school, I mean, like, anything that talks with assembly or sort of microcontrollers. Back in the day, we had like the Motorola 68Ks and stuff like that. But understanding what your C code does, even writing an inline assembly on your own, this is one thing you can do, is go ahead and write yourself a very small, C program, and then try and look at its disassembly, and see if you can, crack open the manual and sort of figure out what's going on.
Yeah. So like Mark says, understanding assembly languages, instruction sets. I remember one of the early things I did was I wrote a hash function. I started out in Pascal and then rewrote it multiple times in assembly, just understanding how every instruction worked and how to maximize performance on that. Honestly, one of the things I do for fun is I read the C and C++ standards, understanding how compilers work. And I mean, I couldn't write a compiler, honestly. It's something I would like to do at some point. And I've written parsers for C. And obviously, I know a bit about the assembly side of things, but it does mean that you can write a compiler, but understanding, what's happening at a lower level in the language, what happens in memory when you have an object and it's, inherits from another object, and, what is a virtual function table, and what is happening on the stack when you call a virtual function, that sort of stuff, is, kind of where we think that's kind of the problems we look at all day in and day out.
Yeah, I'd echo what Thad said, and even more, that brings up the point. One thing you can get from school that's very useful is compiler classes. That is a really good place to sort of the interface for the language and the machine meet. And I think people who understand how the machine works are going to be much better programmers than people who are really far away. You can still be a decent programmer at a high level for big picture things, but it gives you a little extra edge when you're wondering what's going on with some bug or some crash, if you have some inkling about how the machine actually works. And I would highly recommend it to anyone who wants to be a programmer.
And that could be the most fun too. I mean, you might spend 90% of your time integrating two systems, and it's just a lot of reading documentation and writing APIs that work together and things like that. But then you encounter some kind of performance issue where maybe you have to rewrite something in C, or you have to understand, as Mark said, what's really happening under the hood. Why is this code so slow? And that is often the most fun part of the job.
Well, to be fair, it's somewhat of an advantage because I have some of that experience to be one of the few people on a team that knows how to do that. Look at the assembly, go into GDB and say, give me the assembly instructions. Why is this taking too long? Because it's a rare skill, so people value it, and you don't need it often, I would say. If you're a normal software engineer not doing something specifically related to that, you may not need it that much. But when it comes time and you can pull out the big guns and do that, people get really happy very fast.
Mm-hmm.
Yeah, I mean, you can really, that's a skill set that is shrinking more and more we see out there. And the people who, know stuff like that are gold to us, but they're also gold to whatever sort of software team they're on, just to echo what Patrick said.
Yeah. So I have a question about self-modifying code. How does that not get flagged by the antivirus?
There's a couple.
Great question.
Or is the antivirus just that crappy? Because if I was going to write an antivirus, that'd be the first thing I would just flag as a virus.
So not all self-modifying code will get flagged to start with, but you do run into a lot more risk of it. And Mark has looked into that more than I have, so I'll let him talk about it.
Right, and so that's sort of the double-edged sword about all these trust execution environments. On one hand, you would like to have your code somewhere protected so that no one else knows what's going on and can tamper with it. But that also malware authors, virus writers also would love that same thing, so that essentially legitimate processes on the machine can inspect and see what the code is going to do before it's executed. And that's a tug of war in all these sorts of TE environments. I mean, the way it's often solved is that there's some sort of signature that's done so that you at least say where this came from, so that if maybe it fails, but or it does something malicious, but after that, you can trace back to, it came from Microsoft or it came from a non-trusted party. So maybe next time I won't trust him. So you can decide sort of what level of trust you give to each one. If it's one that has no trust, then you better run it, on a clean machine, isolated. But if it's something that came from someone who you trust, then you say, okay, I'll let it run and I'll trust it. It's going to do what I expect.
Yeah, that makes sense. I had this when I was cleaning off this virus off my machine. I noticed that I was kind of expecting it to be more malicious than it was. I went through all my services, and sure enough, there was a service that was, I don't remember the name of it, but it was definitely is a name that stood out. And it, as we said in the beginning, you don't have to be for most cases, you don't have to be Fort Knox. You shouldn't expect someone from CSI or who's the guy from Mission Impossible? I'm totally drawing a blank. The Scientologist. Tom Cruise. You don't expect Tom Cruise to get into your PC. I mean, most of the people,
it's Ving Rhames who does that, right?
Yeah, right. But yeah, but you can actually stop 99% of the problems, and for average people out there who don't have that much at stake, who aren't holding Fort Knox in their basement, they get a phenomenal amount of protection. So very cool.
Looking for Fort Knox hardware is the way to go.
I don't know. Is Fort Knox still significant? Because I heard the whole gold thing. Well, obviously gold doesn't match to dollars anymore. That went away a long time ago. But I think I don't know if Fort Knox even holds that much anymore.
They claim they do, but if you trust the conspiracy theories, they haven't done an audit in a while, so it may all be gone and spent.
Oh yeah, it's just holding UFOs.
Oh, no,
right?
They just spent it and didn't tell anyone.
Oh, okay.
I want the keys to that center of the internet that they visited in the Avengers. That's where I want.
Oh yeah, and was that somewhere in Norway or something?
Yeah.
Yeah, it's always in some frigid environment. Even the Watchmen, right? The main base. I don't want to spoil the movie, but there's one part where they go to an evil lair, and it's always in some glacier somewhere.
Mm-hmm. So do you guys find yourself? So if we want to say the cat and the mouse, the good guys and the bad guys, we'll just all pretend that we trust you, as we talked about, and that you're the good guys. So do you have to put on your bad guy hat and do stuff like to keep up on the latest and greatest of disassembly techniques and that kind of stuff? Do you find yourself how do you, somebody mentioned going to black hat, that kind of stuff?
So,
how much would you say is that? Yeah, go ahead.
So to be a good security guy, you've got to be able to think like the bad guys. If you are, the only difference between us and the bad guys should be, sort of what side we're on. I mean, if you're not thinking about the possible attacks and the possible ways to exploit systems, then you're going to be blind to everything. So in everything, even for most of us, it's not just in what we do now, but in other systems. Like someone is setting up a system to lines to for a fair or something like that. We can see the potential exploits there. I mean, you've got to be able to look at everything as a potential attack.
Every time I got on an airplane, that's the way I think.
Yeah, that doesn't go well for me because I typically start talking about it. I'm like, I shouldn't talk about this. Yeah, listening. So how much would you consider yourself? Yeah, so you guys mentioned that you think in a security mind, you even said as security, I don't know what you said, engineer or security researchers or security, how much of it would you say is that versus people who just say oh, I'm a programmer and don't assign that kind of label? Is there a real difference between programmers who program with security minded and the rest?
There is yeah. I mean, if I would say the big difference is, there's lots of skills that you pick up over time as far as idioms and things like that are, takes lots of training. But the most important skill is being able to sort of understand the threats, the potential threats, the potential attackers, and the potential risks, and what you're willing to risk. I mean, there's a consequence to security, right? I mean, you could have max security and then your users can't do anything, and you don't want that, right? So you've got to sort of at least understand sort of what you want, what your users want, and what the right balance is.
Gotcha. It'd be like having 12 locks on your door. I mean, it's safer, but it just makes
it'll take you a long
more
time to get in. Exactly.
Yep.
Right.
This might get a little meta, but when you're writing the code to do the tamper protection, these processes you said that encrypt a executable or encrypt a library and that kind of stuff, when you're writing that code, do you guys have like a pretty strict set of guidelines you follow to make sure that code itself isn't filled with flaws? Or is it something that you kind of like have an intuitive sense as an individual? When you guys do code reviews, do you have extra things you check to make sure you're not introducing problems?
Well, there's a couple layers of validation, right? I mean, there's one thing where when you're doing the initial design for, is this thing going to work? How are you going to exploit it just from a design point of view? And then there's the actual implementation stuff where that's where the code reviews come in. Does it conform to, the design? And in every design, no design is perfect. There's always, what the, you make trade-offs. You make decisions on, what use protects more, what less, what potential threats are you willing to give up for additional benefits. And even with our the toolkit that we're providing, we're giving the developers the ability to make that trade-off. So there's a couple of like really simple options you can give on the command line that provide sort of a trade-off between the level of security and the level of performance you get. Just you can give a command line like, how frequently do you mutate? How often do you go through the code and do we change stuff? If you do it very frequently, it'll be much more secure, but at the same time it'll be a lot slower. If you do it less frequently, less secure, but it'll code will run faster. And, this is for the application level sort of stuff. And there's similar trade-offs that we make all the time. So, we come together in meetings and talk about the trade-offs, talk about the threats. And then based on those, we make our best calls based on, what we perceive to be, the best interest of the users, or we can provide knobs that the user can tune and say, hey, it'll be up to the user. We'll give them these tools and we'll warn them how to use them and, put it in their hands.
So, but in the toolkit code that you guys write itself, is that such that it's, if the, I guess kind of like public key encryption, you can know the methodology, it doesn't really help you? Or is it, that you have to take special steps in writing those tools so that if someone got a hold of them, they wouldn't be able to now exploit everyone who's ever used your toolkit before?
I think there's a little bit of both. There are part of the way the thing works is that, there are, obviously some secrets that are stored in this thing that's encrypting and decrypting. So knowing how that behaves can give some insights to attackers. But in addition, that's not going to help them with, breaking an existing thing or at least tampering with something, because they're still going to have to, extract all the code and reverse engineer it. So there's a little bit of both.
Yeah, we take some effort, like in our release process, we'll make sure we scrub out a lot of debug messages, any symbols that really say exactly how we're doing something, and let us trace a specific, say, a given instruction all the way through from input until we know where it's encrypted in the final output. We'll make sure we scrub that sort of stuff out. But it's kind of that defense in depth, right? How deep do we want to defend it? And we don't encrypt the entire program with its own methodology, because that would have a huge performance impact.
I was going to ask that, is the toolkit protected by the toolkit?
The code verify library is, by its very nature, has to be able to be encrypted by iProt, but we don't generally encrypt much else of the toolkit with itself, because of the nature of what it is, what the tool set is. The risk analysis just hasn't taken us there at this point. Although I'm sure as Steve hears this, he's like, that's something I can put on the backlog.
Yeah, right. To do Inception system where you just keep encrypting yourself and just watch the binary get bigger and bigger.
So I'm going to ask another question, and you don't have to answer, but you mentioned earlier if you're running on an Intel processor, you get this stuff. What happens if you run the code signed by this on a non-Intel processor, like an AMD processor?
Okay, Intel instruction set.
Okay, all right.
Sorry.
Yeah. AMD will work. We don't support ARM today. It's something we've definitely looked at, but.
Oh, well, how does the Android work then?
Well, there's Intel Android, right?
Oh, I didn't know that. Okay, that
Yeah,
explains
just for
that.
everybody listening, Intel does support Android.
In fact, Intel is one of the
okay.
biggest contributors to the kernel.
Mm-hmm.
I did not know that. I mean, I know iPhones are all ARM, and so I just assumed that Androids were all ARM too. I did not know at all. So learned a lot of things today.
Obviously, we're hoping to change. We're hoping to
new.
change that. We're hoping we can convince Apple we've got a good enough product that they can put it in their phones and stuff like that. That's what Intel is trying to do. But in order to do that, we got to make sure that it runs really well. Runs really well on IA. So that's one of the things we're doing. We're not for the iPhone case, but
yeah,
and there are actually
Apple.
Right.
Yeah, but there are actually Intel phones, actually. Of course, I think the first one just started shipping in the U.S. a short while ago, but I think most of them are like in markets like China and India and stuff like that. I actually saw an ad for one. Where was I? I think it was in Russia when I was traveling there this past summer. I saw an ad for a Zen phone in Russia, an Intel Zen phone.
Oh, very cool. And so Zen is owned by Intel?
No.
Is a division?
So Intel does not sell phones, right? We sell processors.
I see.
So we sell it to.
Got it.
So when you do tamper protection for an Android thing, is there different heuristics that you use? Because obviously battery life is more of a concern, right? So not just performance, speed, but speed has even more of an impact, and not just time, but also battery life, that kind of stuff. Is there a difference go ahead.
So battery life does have a big thing to do, but again, we put that in the developer's hands. It's the same fundamental trade-offs, even on an Intel device and a laptop, right? Which a lot of the form factors are. So again, if you crank it up a lot, you'll get more security, but more processing means more battery drain. So we put that in the developer's hands, but we don't specifically right now have like automated tuning is what we call it when you adjust, the sort of security versus performance trade-offs. But that's something that we're planning to add in future versions.
Cool. Very cool. And so just to explain sort of the deployment from your side. So you give you sell a piece of software, someone buys, installs it on their machine, and then they have those tools that they can integrate into Visual Studio or into their make files or what have you, Gradle, what have you.
Yes.
Actually, you can actually get it for free right now. The beta you can download from our website, and you can download it and try it out without paying for it for this version.
Oh, that is awesome! Wow, yeah, I'm so glad you said. Yeah, definitely. If you're interested in this stuff, you should definitely do that. Everyone at home should check that out. You should build a Hello World and then run this on it. Yeah. And see what happens.
We are very interested. Anything users want to tell us about it, the beta is there because we really want to know what people want to do with it. So if you try it, give us feedback. We want feedback. That we are most hungry for feedback.
Yeah, I mean, if you build something that does some kind of like Monte Carlo estimation or whatever, I mean, tic-tac-toe or whatever, and you run binary tampering on it, and your tic-tac-toe game doesn't work anymore. Let them know. I'm sure they would love to talk to you.
Yeah, so a few more things. I mean, the URL for that is at software.intel.com/tamper-protection. And
okay.
Norm, do we have the Hello World video up there? I recently just did a quick sort of in Visual Studio, just a quick like a 6-minute video that basically shows you how to do a really dumb Hello World style program and run it through iProp. And I'm not sure if it's been published yet. Norm, do you know?
Or maybe it will have had been published by the time this gets published.
Oh, nice use of the past participle or something. Will have had been published.
That's
Good
nice.
Job. I think it's the future past participle.
Future past perfect, I think. Yeah.
Something like that, yeah.
Yeah, Thad went to a good school, so.
Oh, I was on a vacation with my family, and there was a juggler, and there weren't a lot of people in the audience, and so he said, "Who wants to go on the stage?" And my wife yelled, "This guy does!" And so I ended up on the stage, and he said, "Do you know?" And he mentions, I honestly don't remember the lady's name, but it's some lady who could shoot a bow and arrow over her shoulder, and I guess she's some famous lady of that time, 1400s.
Annie Oakley?
I don't remember the name. Oh. That's what it is. He goes, do you know Annie? Do you know Annie Oakley? And I said, And I knew he was going to shoot a bow and arrow. He hit a Coke can off my head. I said, "Did she shoot a bow blindfolded?" And he goes, "You went to public school, didn't you?" And it's like, oh, sad trombone played in the background.
I don't know if we got an answer about whether the video was posted. I'm waiting on pins and needles. We could actually go to the website and see.
I think we may have lost Norm.
I recommend going to the website and seeing if it's there, and if it's not, go back again.
The marketing
we'll
video is up there.
have it up.
I know that.
Mm-hmm. We are actively getting collateral up there based on. I think Mark was at AndevCon this last week, and so he learned some more about what we want to put up on that site. So
actually, I just remastered it like 2 nights ago, so I don't know if Norm's they managed to get it through all the appropriate legal channels or whatever.
You're like a media mogul.
Actually, no, it was my second time using Camtasia. The first time was with the first try, but I've learned so much.
So if you like the sound of the voice on the
faster.
podcast, tune into the video.
That's right.
So do you find like at an environment like Black Hat where I don't know, I know it's both researchers and people trying to explain, it's kind of a mix of people, but the people are they generally receptive to this kind of thing, or are they kind of like, that's not going to be fun when that comes out?
No, yeah. So there's all kinds of people that go there. There's a lot of IT enterprise types. There's coder types. There's government types that want to protect, and so this kind of technology is of high interest. And it's not the same thing as like network firewalls and things. And so you'll see security defense in depth is a phrase you'll hear a lot in the security space, and so there's a lot of people at certain layers, and the people that are focused and interested in binary security, definitely this is right down their alley.
Mm-hmm.
I always thought it'd be cool to go to DEF CON. I'd always be terrified to bring any electronics, but I've never been able to come up with a legitimate work reason to go.
Oh, you
just
need to
don't connect to the network.
Yeah.
Yeah.
I know. I heard what Snowden said. I think I'm not taking the phone with me.
Yeah.
I'll be that guy who goes to DEF CON and leaves with no personal information.
You already are that guy, Jason.
I know, it's already happened to me once.
Yeah, at DEF CON there's a big video of flashing out IP addresses and MAC addresses of devices that have been scanned at DEF CON, and so it's kind of a wall of shame. So definitely keep your devices off.
Yeah.
Or bring them there to test them.
No. And then melt them as soon as you walk out. Yes.
Yeah.
Sell it to somebody else.
Oh, that's nice of you.
We can start a whole enterprise around that, a business model. I think the Russian mafia already has this beat, though.
Oh.
Yeah.
All right. Well, did you guys have any last things you wanted to leave us with? Anything we didn't bring up? Any questions we should have asked you but didn't?
Please encourage your audience to study, more low-level stuff, so we have more people to hire with the right skills.
Yeah, I mean, there's so much to do, and low level is, I think, going to become more and more important. I mean, we had basically 10, 15 years of cloud, and now there's Internet of Things, there's drones, there's autonomous vehicles, there's tamper protection. There's so many different things now that are requiring low level firmware or low level software engineers. That it definitely would be a great field if you're interested in that. You should definitely look at the future. Don't look at right now or look at 5 years ago where cloud was so big. Look at sort of what you want to do, and if you're passionate about that, you should definitely go for it. There'll be tons of opportunity.
Exactly. I mean, if you look at where things are going with IoT, the Internet of Things, I mean, pretty much everything is going to have some kind of microcontroller in it, and it's both a wonderful opportunity and a very scary thing that your light bulbs could potentially be, compromised by someone. Or worse, stoplights, your car. I mean, this is scary, scary stuff. So we need smart people to help solve these problems.
Yeah. In the security developer space, there's a very big demand and not a whole lot of supply. So if someone is looking to diversify or just to create a niche for themselves and they like coding, security space is really a great place to be. There's so many. It's like doing puzzles. If you like to think through hard problems, it's very rewarding, and you'll find a lot of opportunity. And so, get good on tools like Intel Tamper Protection Toolkit, and get good with disassemblers, and you'll find yourself, as you spend time doing that, you're the go-to guy for anything security. And just by getting familiar with some of those tools and some of the thinking patterns that Mark mentioned, you'll find your career growing in a wonderful way.
Yeah, start by trying to break stuff and then worry about securing it later. That's my recommendation there.
But it'll keep you up at night. I don't know. I remember back in school I would read like Kevin Mitnick's book about social engineering or whatever, and be like, oh man, this is not good.
Yeah,
everything in the world is just vulnerable.
Yeah, or go play EVE Online. That'll help too.
Wait, what?
Go play EVE Online.
What's the connection?
That'll keep you up at night.
Oh, I see.
Yeah, you will stay up all night playing EVE Online.
Well, no, managing the security and things like, and trust and things like that.
Oh, okay.
Oh, I see the social network there. Okay, that makes sense. I've never played EVE Online, but I've heard crazy stories of 20,000 hours of work getting just destroyed in some battle.
Yeah.
It's unbelievable.
Well, no, actually, even worse than that, 20,000 hours of work gets destroyed by someone who you trusted, who ended up, turning on you and stealing your stuff.
And that's supposed to be fun? It sounds like real life. I have a real life.
That part of it's probably...
Again, for people who think that way, it can be interesting. How do you protect?
It sounds awesome.
How do you protect?
I know somebody who doesn't even play that much, but through his, I guess, social graces, is able to just have incredible wealth on EVE Online, just because he's on the top of kind of, I guess, I don't want to say a pyramid scheme, but he's built a multi-level marketing.
Exactly. It's a great model of the real world.
Right. Cool. Thank you guys so much for coming on the show. I'll post a link to your email addresses if people want to reach out to you. If they want to come and work with you guys, or if they just have questions about tamper protection, or if their trial expired and they want to beg you guys for another 30 days or something. So we'll have a way to contact you guys. And this has been absolutely fascinating. So thanks again for coming on the show. It's totally awesome.
Perfect. Thank you for having us.
Thanks, everyone.
Thank you.
Thanks, guys.
Pleasure.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.